Good morning. Today we are going to discuss about the closed loop system and the closed loop system of the block diagram, negative feedback versus positive feedback system, servo problem versus regulator problem, and how to develop the block diagram. First we see the closed loop system. A closed loop system, also known as the feedback control system, is control system which is used the concept of all open loop system as its forward path but has one or more feedback loops. Hence, its name are path between the output and the input. It is the closed loop control system that is controlled by the final control element and the recorder control is TR and the TM. There is a control system of set tank heater. There is a heater by using the sensing element of temperature measuring element and W, TA, this is a process, and also the input by W by TA, T and the TA. Let us consider a liquid stream at temperature TA enters uninsulated when the stirred tank at constant flow rate of W is mass per time, and it is desired to maintain the control, either control the temperature in the tank TR. TR is nothing but the control by means of control. If the measurement of tank temperature Tm difference from the desired temperature TR, the controller sends the difference or error summation on TR minus Tm and the changes the heat input in such a way to reduce the magnitude of epsilon. If the controller changes the heat input to the tank by an amount of proportional to epsilon, we have the control system. Like the source of heat input is nothing but of Q. Q is the heat input, maybe electricity or steam, production by the electricity either or by the steam. If an electrical sources were used, the final control element might be a variable transformer that is used to adjust the current to a resistance heating element. If steam were used, the final control element could be control valve that adjusts the flow of the system. In either case, the output signal from the controller should adjust the Q, the heat of Q from the steam, or either by the electricity in such a way as to maintain the control of the temperature in the tank to heat by the temperature. This is the development of block diagram for the simple control system. First, we have the set point of by using the whole control system that can be maintained by the comparator and the controller. And next is the final control element. There is a final control element by the control element to the process. We have to given as a load, and the output is nothing but of a control variable. There is a transfer functions of output is directly proportional to the input either, and it can be once again by the open loop, the measuring element, and the TM is nothing but of measured variable to the set point. The whole can be controlled by the controller mechanism and the comparator. TR is nothing but of a set point, that is a positive one, and the TA is nothing but of a load for the process, and the output is nothing but of a control variable. Control variable is directly proportional to the TR. From the computational purpose, it is convenient to present the control system. Already we have seen the figure 1 above by means of the block diagram, the figure below. Such a diagram makes the much easier to visualize the relationship among the various signal new terms which appears in the figure 2, the block diagram, or the set point and the load. The set point is the synonym for the desired value of the controlled variable. The load refers to a change in any variable that may cause the control variable of process to the change. In this example, the inlet temperature TA is a load variable. Other possible load for the system are changed and the heat loss is nothing but of Q can be lost, TR and the TM. The control system of the shown in the figure 2 is called the closed loop system or a feedback system because the measured value of the control variable is returned or fed back to a device called comparator, comparator. In the comparator, the controlled variable is compared with the desired value of the set point. That set point. If there is any difference between the measured value and the set point, an error is generated. This error enters a controller, which in turn adjusts the final control element in order to return the control variable to the set point. From the among figure 1 and 2, there are negative feedback versus positive feedback system. The feedback principle, which is illustrated by the block diagram, figure 2, involves in the use of control variable T to maintain itself at the desired value of TR. The arrangement of the apparatus that the block diagram 2 is often described as a negative feedback to contrast with another arrangement called positive feedback. The negative feedback ensures that the difference between TR and TM is used to adjust the control element so that the tendency is reduce the error. For example, assume that the system is steady state and the T equal to TM and the TR. If the load Ta should increase, T and Tm could start to increase, which could be cause of the error of the feedback, negative feedback systems. Which proportional controller decreases in error could cause the controller and the final control element to decrease the flow of heat to the system, which results that the flow of heat would eventually to reduce the value such that T approaches to the Tr. If the signal to the comparator were obtained by adding Tr and Tm, we could have the positive feedback system, which is inherently unstable. Let to note that that is the true. Again, assume that the system is at steady state and that T equal to Tm equal to Tr. And the Ti were to increase, T and Tm could increase, which could cause us the signal, the comparator to increase, with the result that the heat to the system could increases. However, this action, which is just the opposite that needed, could cause T to increase further. It should be clear that this situation could cause T to run away and control could not be achieved from the figure 1 to the 2, that the block diagram. For the reason, positive feedback could never be used initially in the system of figure 2, that the block diagram. The servo versus regulator problem. The control system of figure 2 can be considered from the point of view of the ability to handle either of two types of situations. The first situation, which is called the servo mechanism type, is nothing but a servo problem. We assume that there is no change in load and that we are interested in changing the bath temperature according to some prescribed functions of time. For this problem, the set point Tr could be changed in accordance with the desired variation in bath temperatures. If the variation is sufficiently slow, the bath temperature may be expected to follow the variation is Tr is very closely. There is the occasions when the control system in the chemical industry will be operated in the manner. For example, one may be interested in varying the temperature of a reactor according to a prescribed time temperature pattern. The tracking of the missiles and the aircraft and the automatic machining in intricate parts from the master pattern are well known by the servo type problem only. The other situation will be referred to as the regulator problem. In this case, the desired value Tr is to maintain the fixed and the purpose of the control system is to maintain the control variable at Tr in the change in load Ta. This problem is very common in the chemical industries and a complicated industry process will often the many self-containment control system which are maintains particularly process variable at a desired value. These control system are regulated type. Next, we see the development of block diagram. Each block in figure 2 represents the functional relationship existing between the input and output of the particular component. In block diagram representation of the control system, the variables selected are deviations, variables, and inside each block is placed the transfer function. The transfer function is the output is directly proportional to the input, relating the input-output pair of the variables. Finally, the block are combined to give the overall block diagram. This is procedure to be followed in the developing of the block diagram process. Thank you.